Chapter 3.1, Solving Problems with Fractions. Again, the try these involve fractions, kind of makes sense. These are all linear measurement problems, so nothing to do with area or volume. We'll get to those in other chapters in the workbook. Review of dividing fractions. So remember, you want to, I'm going to change this to blue. You want to flip the divisor. So mathematical word is take the reciprocal. So that'd be 1, and then you multiply by that reciprocal. So that's 1 times 8 over 7. That's just going to be 8 over 7. 1 times anything is itself. Second question, we're adding. So we need a common denominator. Does 8 go into 16? Yes, it does. So 16 is our common denominator. So I always copy out the fraction that I don't have to change. Show the fraction that I do have to change with the correct denominator, and then figure out what the new numerator needs to be. So I need to multiply by 2. Okay, so a dot in the middle, not as a decimal down below, also means multiplying. Often it's a little bit easier. It doesn't get confused with an x that you might use as a variable. So we tend to use that in high school. Just be aware of that. So that's going to be 6 over 16. Add those together. We keep the denominator the same. So my answer is going to go up here. And then we add the numerators. Okay. Third one, we're dividing again. So I'll show my work above. It's going to become a multiplication of 8 over 1. And then remember, you can multiply the numerators, multiply the denominators, and simplify. If you can see, 4 goes into itself once, into 8 twice. So a common factor between a numerator and a denominator, then you can do that first. That'll be 6 over 1, which is 6. Okay, and then this is straight multiplying. Here, notice 4 goes into 8, but I cannot divide that out because they're both in the denominator. So this is just going to be 7. 1 times 7 is 7 over 32. Okay, so first example here. Katie is a cabinet maker. A client wants her to build this cabinet with equally spaced shelves. She plans to use 3/4 inch birch plywood. How far apart are the shelves from the bottom of the shelf to the top of the next? Okay, so basically each of these needs to be the same, and we want to know what that distance is. Okay, so the open space. So first of all, it says how many boards will Katie need to build the top, the bottom, and the shelves? So take a look at it. She'll need 1, 2, 3, 4, 5, 6 of those boards that are all equal in length. If each board is a 3/4 inch thick, so that means this thickness is 3/4, this is 3/4, this is 3/4, this is 3/4, 3/4, and 3/4. So if all of each of those are the same, 3/4, what is the total thickness of the boards? If she just got them prepared and put them in a pile, how high would that pile be? Well, you have 6 that are each 3/4. So again, we're multiplying here, so you can divide out. You can multiply, that's like 6 over 1. Multiply numerators and denominators and then simplify. Or you can see 2 goes into 4 twice, into 6 3 times. 3 times 3 is 9 over 2. Okay, the 2 stays the same. So 9 over 2 inches. What's that? As a mixed number, we can show that as 4.5 inches. As a decimal, it's 4.5. Okay, so that's the total thickness of the boards. How much of the cabinet height is left for the space between the boards? So basically, we know from the very bottom to the very top is 7 feet 3 inches. Of that, 4.5 inches is actually used up by the wood. So what's left over is the actual air, the space in between. So now here, this is all in, this is given in feet and inches, and this is just in inches. So I'm going to convert, if this was more than 4, I would not do any conversions, but it's less, so I'm going to convert this, so multiply by 12, and that's going to be, what's that, 84 plus 3. So that's the total height of the shelf, and then minus, and if you want to use decimals here, you might find it a little bit easier, okay, 4.5. So that's going to be 87 minus 4.5. So maybe I'll show it here, 87 minus 4.5. So try it without a calculator. 4.5, well, if we subtract 4 from 87, we get 83. And then subtract another 0.5 would be 82.5, or 82.5 inches. Okay, you could convert back to feet and inches, but remember our goal in this question is to find the distance between shelves, so likely it may not even be a whole foot. So how many spaces are there between the boards? So there were 6 boards, but there are 5 spaces, so don't get tricked by that. 6 boards gives you 5 spaces. So how far apart? Well, then we take our 82. Again, you can go back to decimals if you want. If you find that easier, divided by 5. Okay, and try this without a calculator. Shouldn't be too bad. So 5 goes into 8 once. 3, bring down the 2. 5 goes into 32 6 times. So that's 30. Bring down the 2. Decimal there, or sorry, subtract to get to, then didn't bring down the 5. 5 goes into 25 5 times. Okay, so that gives you 16.5 inches. Okay, or 16.5 inches. And take a look, this answer says in inches. So we could convert back to feet in inches. We know that there's 12 inches in a foot. So if we have 16, that would mean it would be 1 foot, 4.5 inches. Okay, but it didn't ask for that. Not a bad idea to practice though. Okay, so that's that example. Then this example here, Caden is a baker. He cuts a 14.5-inch roll of dough into 1.25-inch slices for cinnamon buns. That's often how they're made. How many buns can he make from one roll? So think about this. So this 14.5 is this whole distance here. And how many 1.25s will he get, right? So really what we're doing when you think about that is the long way you could keep subtracting, right? But that takes a long time. You want to divide to figure out how many times it went in there. So what equation can you use? We're going to divide the total length by 1.25. Okay. Again, we're going to try not to use our calculator. It says rewrite the equation using improper fractions. So convert 14.5. That's going to be 28 plus 1 is 29. Okay, it's 29 over 2. I didn't leave a lot of space, but anyway, divided by, that's going to be 5 over 4. And then that's the equation. So let's just finish it down here because there is space. So now for dividing, remember we invert the divisor and multiply. So invert means take the reciprocal. Notice how 2 goes into itself once, into 4 twice. So we can simplify that. And that's going to end up being 29 times 2 is 58 over 5. Okay, so now it says how many buns. 5 doesn't go into 58. So we're going to be approximate here. So what does it go in? So if you go 5 into 58, that goes in once. Bring down the 8 once. And so really this is 11 3/5. So it makes, 11 whole buns and 3/5 of another bun. And sometimes you'll see at bakeries, they'll have like sort of one-offs or things like that, things that didn't quite, maybe weren't the right size in order to sell at the certain price. That would be this case. If this was at home, I'd probably just eat it myself. Not a really big deal, right? Example 2. A jack raises a car 3/16 inches for each stroke of the lever. How many strokes are needed to raise a car? So I have to admit, I've never changed a tire. I have Automobile Association to do it, but basically you put this on the ground and, well, I'm not sure how far that goes up, how it's attached underneath the wheel. So I'm not sure how high that is, but it's basically so to lift the car up so that you can actually get the wheel off. So there's a lever that you push down. So for each push down, the jack moves up 3/16 of an inch. So it keeps moving the car up. So in total, we want to raise it 1.5 inches. So write 1.5 using a denominator of 16. Well, mixed number, that would be 1, and then basically we're changing this to have a denominator of 16. So we would multiply top and bottom by 8. That as an improper fraction, remember we go 1 times 16 plus 8 is 24 out of 16. Okay. Reason why we're converting to a denominator of 16 is because that's how much, that's the denominator of how much each stroke rises. So we want to know if this total amount is 1.5, how many of these strokes we need. So it's very much like the cinnamon bun question. We're going to divide. So 24/16 divided by 3/16, that's what this is. I guess they didn't, yeah, so here, oh, sorry, not that. I'm going to erase that. Go back to here. This is how much the stroke rises, 3/16. So we want to know how many of these in 24/16. So then we show this as 24/16. Invert and multiply, and you'll notice the 16s divide out. That's why we did it, made it so much easier. And then 3 goes into itself once, into 24 8 times. So we get exactly 8 strokes needed to raise 1.5 inches. Using multiplication, so our answer is 8. We want to multiply that by the height of each stroke, which is 3/16. Okay, 8 goes into itself once, into 16 twice, and we get 3/2, which is the same as 1.5. And that's what we wanted the car to rise to. So that confirms our answer. And that's it.